All right, let's talk about one of the biggest, most critical decisions you'll ever make when you're designing a system, picking your database. I mean, get this right and your app is going to absolutely fly. But get it wrong? Whoa, you're building your entire house on a shaky foundation. So the big question is, how do we get it right?
Seriously, think about it. When you're architecting a new system, what's that one single choice that's going to ripple out and affect everything else? We're talking your speed, your costs, your entire future, and whether you can even scale. What is it?
You guessed it. It's your database. And here's the trap so many people fall into. They just pick what's popular or what they already know. That can be a massive mistake. So in this explainer, we're going to break down a super clear framework to help you choose the perfect database for what you actually need.
Okay, first things first. The absolute biggest mistake you can make is to start looking at solutions before you even understand the problem, right? You got to stop thinking about specific tech for a second and really deeply understand what your system needs to do. Because let's be real, the best database in the world is totally useless if it's the wrong tool for your job.
So the first big question, how are you planning to grow? There are two main paths here. You've got vertical scaling, which is basically just buying a bigger, beefier server. Think of it like trading in your regular car for a giant monster truck. Then there's horizontal scaling. This is where you add more servers to share the load. So instead of one truck, you have a whole fleet of cars. And this is a really fundamental divide, you know? Traditional relational databases are champs at scaling up, but a lot of the NoSQL databases were built from day one to scale out.
All right, next up is a really crucial trade-off. It's all about consistency. On one hand, you have strict consistency. This is where every single transaction has to be perfect, immediate, all or nothing. You know, like a bank transfer. You can't have the money leave one account and not arrive in the other. That's what we call ACID compliance. But on the other hand, maybe you can live with eventual consistency. This is where data might take just a moment to sync up across the whole system. The payoff? You get incredible speed and availability. Think about a social media feed. It doesn't matter if a like shows up a second late. This choice right here is going to dramatically narrow down your options.
And we're not done yet. You've got to dig into your workload. Ask yourself, are we going to be doing more reading or more writing? What do our queries look like? Are they simple lookups, like finding a user by their ID? Or are they super complex analytical questions that have to join tons of data together? And what about resilience? I mean, does your system need to survive if a server goes down? What about a whole data center outage? Once you answer all these questions, you've basically created a perfect blueprint for exactly what you need.
Okay, so now we have our blueprint. We know what we need. Now we can finally go shopping. So let's meet the big, diverse family of databases and see how we can match them up to the needs we just figured out.
So, this right here, this is your cheat sheet. Let's run through it real quick. First, you've got your relational databases. These are the classics, the old guard. Think of a perfectly organized spreadsheet. They're awesome for things like financial records, where every little detail has to be perfect. Then you have document databases. These are way more flexible, kind of like a digital filing cabinet for all your JSON files. Perfect for when your data structure might change over time. Next up, key value stores. These are all about one thing: pure, raw speed. It's just a simple, lightning-fast dictionary, which makes them incredible for things like caching. Then there are time series databases, built specifically for data that has a timestamp. Think IoT sensor data or system metrics. Columnar databases, they're your analytics powerhouses. They store data by column instead of by row, which makes running massive queries for business intelligence just blazing fast. And finally, graph databases. These guys are all about the connections between things, the relationships. That makes them a natural fit for social networks or spotting complex fraud patterns.
Okay, so you've picked the right type of database. Awesome. But wait, there's another huge decision you have to make. Are you going to manage this thing yourself, or are you going to let someone else handle all the heavy lifting for you?
And that's where managed databases come into the picture. The best way to think about it is like renting a fully serviced apartment versus owning a house. With the apartment, the landlord handles all the maintenance, right? Well, with a managed database, the cloud provider, your AWS, your Google Cloud, your Azure, they handle all that messy stuff for you. We're talking security patches, backups, all those complex configurations. Poof, it's just done. And this is the why it's so powerful. When you go with a managed service, you get all this incredible stuff right out of the box. Automatic backups, point-in-time recovery, scaling with just a click of a button, top-tier security and monitoring, it's all there. And what that really means is your team gets to focus on what they're actually good at, building your amazing application instead of spending all their time being database admins.
But hang on, here's a real pro tip for you. The most sophisticated modern systems, they almost never rely on just one single database. Instead, they embrace this really cool idea called polyglot persistence. It's a fancy term that just means using different tools for different problems.
So this idea of polyglot persistence, what does it actually look like? Well, for example, you might use a rock-solid relational database for your critical financial transactions, right? But then you use a super flexible document database for your product catalog and a lightning-fast key value store for your user sessions, all inside the same application. This is super common in a microservices architecture, where you break your app into these little independent services, and each one gets to pick the absolute best, most perfect database just for its one little job.
And really, that brings us to the single most important takeaway from all of this. The golden rule. Don't go searching for one database that's just kind of okay at everything. No. The goal of a great architect is to look at each part of the system, figure out its specific needs, and then pick the specialized tool that absolutely crushes that one job. So, let's wrap this all up into a simple 4-step checklist you can use every time. Step 1. Analyze your needs. Think scalability, consistency, and your workload. Step 2. Explore the different database families to find the best match. Step 3. Ask yourself, can a managed service make our lives easier and let us focus on what matters? And finally, Step 4. Decide if a modern multi-database architecture is the smartest play for your system. So there you have it. We've looked at the map, we've gone through the options, and we've talked strategy. You now have the framework to go way beyond just picking what's popular and instead choose what's truly powerful for your project. So the only question left is, what database are you going to choose to build the future on?